So now I am going to tell you about another sum. This is also requested by a student. So it is also used to find out the confidence intervals, or we can say that confidence limits. So once we see the question. The mean and standard deviation of the breaking strength of 100 cables tested by a company are 180 lbs and 25 lbs. Find 90% and 95% confidence limits for the mean breaking strength of all cables manufactured by the company. This lbs is also called as pounds. Okay, it is a unit for force. Okay. Yeah. So what they are asking us to find out is 90% and 95% confidence limits for mean. That means single mean they are asking us to find out, and they gave mean and standard deviation they gave. Okay. First we'll write what are the given values. So given that mean x bar equals to how much? 180 lbs, and standard deviation, that means S, standard deviation S equals to 25 lbs, and N, sample size, how much they give here? Sample size, okay, strength of 100 cables tested by a company, that means sample, this is, okay, N, sample is denoted by what? N, that is 100. Okay, so now to calculate the confidence intervals, or else we can say limits. To calculate the confidence intervals, the following formula is used. The following formula is used. What it is? So x bar plus or minus T alpha by 2, comma n minus 1 degrees of freedom into S by root n. Okay, S by root n. This is the formula in order to calculate confidence limits. Why we have to use here T distribution? Why? Because here whenever they give sample mean and sample standard deviation, we have to use T distribution. When they give population standard deviation, at that time we have to calculate, we have to use chi-square distribution. Remember this thing, this is the tip. I can say that one. So what is the tip? Whenever the sample standard deviation and sample mean is given, we have to use T distribution. When they gave population standard deviation, at that time we have to use chi-square distribution. So in my previous video it is there. Okay. Okay, now what we have to do is sorry, so 90%. Okay, so to find 90% confidence interval, alpha value is, what we have to take? Alpha value is 10% or else 0.10 we can take. So now alpha by 2 is how much? 0.10 by 2, that is nothing but 0.05. Okay, so now the critical value at T 0.05, that means 0.05 is called as level of significance with 100 minus 1 degrees of freedom. Here what is the degrees of freedom? N minus 1. So 100 minus 1 degrees of freedom is 1.1 660. So this is critical value in the sense what? Nothing but table value. Okay. So table value how much? 1.660. Now we have to calculate this one. So you all know that if you watch my previous videos, you can able to say this one. What is this term is called as? This term is called as margin of error. Okay, ME. Only this term is called as standard error. Okay, so now we are going to calculate what? Margin of error. Okay, so margin of error equals to, what is the formula? T alpha by 2 with n minus 1 degrees of freedom into S by root n. Okay, so this is critical value, no? So what is critical value? 1.660 into S in the sense what? Here they have given 25. Okay, so 25 divided by root n. Root n in the sense what? Root 100. Okay, so now we'll calculate this one. 1.660 into 25 divided by root 100. So that equals to 2.500 into how much? 1.660. So that equals to 4. So ME equals to 4.1500. So this is maximum likelihood estimator. So now we have to calculate confidence interval at 90%. Okay, so confidence interval at 90%. Okay, at 90%. So what is the formula? X bar plus or minus ME, margin of error. X bar plus or minus margin of error. So what is X bar here? X bar is 180. Okay, so 180 plus or minus margin of error is nothing but 4.15. Okay, so 4.15. So we can write this one as 180 minus 4.15 comma 180 plus 4.15. Okay, so now we'll calculate the confidence limits at 90%. Okay, 180 minus 4.15 equals to how much? 175.85. Okay, comma 180 plus 180 plus 4.15 equals to how much? 184.15. Okay, these are the confidence limits at 90%. So now we have to calculate what? At 95%. Why? Because they asked that at 95% also we have to find out the confidence limits. So now we are going to find out at 95% the confidence limits. Okay, so 95% at 95%. So 95% confidence interval. Okay, what is alpha value? We have to take alpha value, that means level of significance 95% in the sense 5%, or else we can say that 0.05%. Sorry, 0.05 we can say, or else 5% we can say. Why? Because 100 minus 95 is nothing but 5. So that's why we can say level of significance as 5% or else 0.05. Okay, so then alpha by 2, what is the alpha by 2 value? 0.05 divided by 2 is nothing but we will get 0.025. Okay, so the critical value at t 0.025, level of significance is nothing but 99. Okay, n minus 1, that means 100 minus 1. So 99 degrees of freedom is 1.984. Okay, this is the table value, critical value or table value, we can say the both are same. So now what we have to calculate is margin of error, ME. Now we have to calculate what? ME, margin of error. Okay, so what is ME formula? ME equals to T alpha by 2 at n minus 1 degrees of freedom into S by root n. S by root n. So here what is the critical value? 1.984 into S by root n. What is S value here? S value is 25. S value is 25 by root n in the sense root 100. Okay, so that is equal to 1.984 into 25 by 100. Okay, so 25 divided by root 100. How much? 2.5. So into 1.984. So that equals to how much? 4.9600. So here the maximum, like the margin of error, the margin of error is how much? 4.966. Now we have to calculate the confidence limits at 95%. What is the formula? X bar plus or minus margin of error. So what is X bar? X bar is 180 plus or minus margin of error in the sense what? 4.9600. So 180 minus 4.9600 comma 180 plus 4.9600. So that means how much we'll get? 180 minus 4.9600. That equals to how much? 175.0400 comma 180 plus 4.9600 equals to how much? 184.9600. So these are the confidence limits at what? 95%. Okay, so at 95% this is the confidence limits, and at 90%, so these are the confidence limits. Okay, so hope you all understand. Okay, and next video we'll see, the next problem we'll see. So that is, see here, the average hourly wages of a sample of 150 workers in a factory A was rupees 25.6 with the standard deviation of rupees 1.08. The average hourly wages of a sample of 200 workers in a factory B was rupees 28.7. This is 28.7 with a standard deviation of rupees 1.28. Find 99% and 95% confidence intervals for the difference of means. What they gave? They gave mean values and also they gave standard values for two samples. Okay, two samples they have collected from factory A and factory B, and hourly wages, how much they are going to pay for 150 workers and 200 workers for different factories, and they are asking us to find out the confidence intervals, or else we can say confidence limits. Okay, yeah, first we'll write what are the values they have given. So given that, so here two samples we are having, no? So that means first sample I will say x1 bar, we will denote with x1 bar. So what is x1 bar here? A factory mean in the sense x1 bar how much? So 25.6. Similarly x2 bar equals to 28.7. Okay. Next, standard deviation. S1 equals to S1. Standard deviation 1.08. Next, S2 equals to 1.28. Okay. Yeah. Next, N1 equals to how much? 150. Okay. 150 sample. No? So, N2 equals to 200. Okay, 150 workers and 200 workers. So now we have to calculate the confidence intervals for the difference of means. Okay. So the difference of, so we'll write the confidence intervals. The confidence interval for the difference of means, for the difference of means, we use the following formula. We use the following formula. So what is the formula? X1 bar minus X2 bar plus or minus Z alpha by 2 comma or else into square root of S1 square by N1 plus S2 square by N2. So here if you observe, here we are not using any degrees of freedom. Why? Because here the sample size is greater than 30. That means it comes under large sample. So that's why we used what? Normal distribution, Z-test we used. So when we use Z-test, at that time we consider only level of significance. We won't bother about level of degrees of freedom. Okay, we just consider the level of significance. That means alpha by 2 values only we will consider. Degrees of freedom we don't consider when we are using what? Normal distribution. That means Z-test. Okay. Yeah. So here 99% and 95% we have to find out. Okay, first we are taking 99%. So at 99%, alpha equals to how much? 1%. 1% in the sense what? 0.01, or else we can say 1%. Okay, then alpha by 2 how much we'll get? 0.005 we'll get. Okay, so the critical value at Z alpha by 2, that means Z 0.005 is 2.576. Okay, this is the table value 2.576. Okay, now we are going to calculate what? This term we have to calculate. See, this full term is called as margin of errors. Only this term is called as what? Standard error. So first we'll calculate the standard error. So standard error equals to, what is the formula? Square root of S1 square. What is S1? 1.08 whole square by N1. What is N1? 150 plus S2 square. What is S2? So 1.28 whole square divided by N2. What is N2? 200. Okay, we will calculate now this one. Okay, so 1.08 whole square divided by 150. How much we got? So square root of 0.0078 plus 1.28 whole square divided by 200. So how much? 0.0082. So we have to place this term plus 0.0078. So that equals to how much? Square root of 0.0160. Okay. So square root of 0.0160. So what is the value? So standard error equals to 0.1265. So standard error value we got this much. Now what we have to calculate? Maximum error. So margin of error. So margin of error in the sense what? What is the formula of margin of error? Z alpha by 2 into SE. Okay. So Z alpha by 2. What is Z alpha by 2? Table value 2.576. Okay. 2.576 into standard error how much? 0.1265. So 0.1265. So 0.1265 into 2.576. 2.5. Okay, we wrote the values correct only. So we will multiple. So 2.576 into 0.1265. So that equals to, so margin of error value equals to how much? 0.3259. 0.3259. Okay. So now we have to find out what? Confidence interval. So the confidence interval is at 99%. The confidence interval is, see, x1 bar. What is x1? 25.6. Okay. So 25.6 minus x2 bar. Here the formula x1 bar minus x2 bar. No. So x1 bar is 25.6. x2 bar is 28.7. Okay. So 28.7 plus or minus margin of error. Okay. This full is called as margin of error. No. So that's why plus or minus how much? 0.3259. Okay. So we'll do now this one. So 25.6 minus 28.7 equals to how much? Minus 3.1000 plus or minus 0.3259. Okay. So now we have to find out the confidence limits. First one is minus 3.1000 minus 0.3259 comma minus 3.1000 plus 0.3259. Okay. So minus 3.1000 minus 0.3259 equals to how much? Minus 3.4259 comma this one minus 3.1000 plus 0.3259 equals to minus 2.7741. Okay. So these are the confidence limits at 99%. Okay. So again they asked us to find out 95% confidence limits also. Okay. So 95%. So 95% in the sense what? Alpha value equals to 0.05. 5%, no? So that means what? 0.05. That means alpha by 2, how much we'll get? Alpha by 2 equals to 0.025 we'll get. Okay. So if you have doubt, once we'll see. 0.05 divided by 2. 0.025. Okay. Yeah. So now the critical value at Z 0.025 is 1.96. Okay, the critical value is how much? 1.96. The critical value and the table value both are same. Okay, 1.96. So now we have to calculate what? Margin of error. Margin of error in the sense what? This full term is called as margin of error. Already we calculated this one. This one will not change for 99% or else 95%. So that's why this value is how much? 0.1265 into what? Z alpha by 2. Okay. So margin of error is 0.1265. 0.1265 into how much? 1.96. So margin of error equals to 0.1265 into 1.96 equals to how much? 0.2479. So this is margin of error at 95%. Now we have to calculate what? Confidence limit. So we know the formula is x1 bar minus x2 bar plus or minus ME, margin of error. So x1 bar in the sense what? Same now, 25.6 minus 28.7. So as we did here, plus or minus margin of error is 0.2479. So this value will not change, no, same we will get minus 3.1000 plus or minus 0.2479. Okay, so first we have to use minus 3.1000 minus 0.2479 comma minus 3.1000 plus 0.2479. Okay, minus 3.100 minus 0.2479 equals to how much? Minus 3.3479 comma minus 3.1000 plus 0.2479. How much? Minus 2.8521. Okay, so these are the confidence interval values at 95%. Okay, hope you all understand. Okay, so if you have any doubt, please comment. So keep watching and thank you for watching. Like, share, subscribe. Bye, take care.